Let's look at some problems from chapter 28. This is problem number 64, and we have given some charges in as a function of time as a q1 equals to 3t squared plus 6t, q2 equals to 4t squared plus 2t, and q3 equals to 2t squared plus 10t. So for part A, we have to find out the current in each of the three trials. So for Q1, so we have this. So as we know, current is the rate of change of charge. So for Q1, the corresponding current, let's say it is I1, will be just dq1 over dt. So you just have to take a derivative of q1 with respect to t. So it will be 60 plus 6. Similarly for q2, 40 squared plus 2t. So its corresponding current will be I2 equals to 80 plus 2. And similarly for Q3, the current I3 will be 40 plus 10. And these are the corresponding current in each of the three trials. So for part B, we have to plot each of the currents we estimated on the same graph for t equals to 0 to t equals to 5 seconds. So it's quite easy and very simple problem. So you just have to plug in t equals to 0 to t equals to 5 for each of these current values. So when you put t equals to 0 for I1, when you put t equals to 0, it will be 6 times 0 plus 6, it will be the 6. This is how you can complete the table from t equals to 0 to t equals to 5. For example, if t equals to 5, it will be 6 times 5 plus 6, it will be 36. Similarly, you can do the same for I2 and I3, and you will be able to plot the graph of current versus time in second, current in ampere. So it's very simple graph. For I1, you can make it red line. For I2 this, and I3 this, so to distinguish each of the corresponding graphs from one another. So for I1, so the first point when t equals to 0, it is 6, so somewhere here, and 12 somewhere here, and so on and so forth. For t equals to 2 seconds, so it is observed that all the graph intersect at this point t equals to 2 seconds. All the graph have the corresponding current as 18 ampere. So this is how you can plot the graph. And for part C, so you have to find out in which cases the current is greatest after 10 seconds, and in which case the most charge passes by the location in 10 seconds. So the current is greatest if the coefficient of t is greater. You can look at corresponding I1, I2, and I3. So obviously for case 2, the I2, the current will be maximum, the greatest, because the coefficient of t is 8. So for case 2, the current will be greatest. So for case 2 as well, the so question asks you to most charge. So obviously the square of t will give you the amount of charge. So obviously again for this case, for the case 2, the coefficient of the square term of t has the coefficient, the maximum coefficient. So that's why it will be the current will greatest, because the square term will dominate in determining the amount of charges that has passed by the location after 10 seconds. So this completes the problem number 6.